Hello.
Good evening, sir.
Good evening. Good evening. Let's wait for think people are joining. After that, we'll start in 5 minutes.
Sir, I have doubt regarding registration.
Not,
Yes, sir.
yeah. So registration and all, please contact to support team. They are handling this kind of task. Okay, they will rectify.
Good evening, sir.
Yeah, yeah. Good evening. Good evening. So let's wait for some time. We'll start in 5 minutes. Okay? I think people are joining.
Sir, is this
Okay, sir.
summary class or quiz class?
No, no, it's not quiz class. It's basically activity practice. Basically doubt session.
So there will be no summary, okay? Right?
No, I think one session has been already happened, right? On Friday.
So, actually, I have not attended before session due to the result one, but I want to ask that how to do that EMQ1 assignment. I didn't get it.
How
So, if
to
you can, EMQ assignment. There are two
how to
assignment,
s-
na?
how to submit the file.
Yeah, how to submit that file.
I think just go in week 4, right? In week 4 there is one instruction video. Okay,
Okay, sir.
just watch first 2 to 3 minutes. You
Okay.
will get idea how to submit the EMQ file, right?
Okay, sir.
Or
Okay.
you can go through the week 5 open session. I have already discussed there how to submit the EMQ. It's better good to see the instruction video in week 4. Okay.
Okay, sir.
Yeah. Is there any other session is going on? Very less of you have joined it. Only
So your
13.
voice is low.
Yeah. So I was asking, is there any reason very less people have joined, or is there any session is going on?
No, sir, it was not pre-scheduled. It is scheduled today only.
Okay. But normally we are having sessions on Sunday, right? 6 to 8.
Yeah, sir, but there was no schedule for today. It's scheduled in the morning. Yesterday there was no schedule for the class today.
Yes, sir.
Okay. Okay, no problem. We will discuss the thing. They can watch on uh, YouTube later. Okay, so I will go activity wise, right? Okay. So you guys have any doubt in any activity, do let me know. Okay. Concepts are clear to everyone?
Yes, sir.
Sir, some concept clear, some have doubts.
In which concept you heard of?
Lecture 6.2,
Topic name. Tell me the topic name.
combination, sir.
Have you gone through each lecture video?
Yes, sir.
Combination you heard out, right? Okay, I will
Yeah.
tell you. Okay, any one of you doubt in activity 6.1?
Yes, sir. First one and fourth one.
First one and?
Fourth.
Fourth one. Okay. Any one of you have done the question number first?
Yes, sir, I am done. But sir, I have a little doubt. Uh,
Okay.
sir, I apply with formula but didn't get any answer. But I try to solve other way. I can
Mm-hmm.
solve it.
Okay. What was your approach?
Sir, this is a three option, true, false, and
Mm-hmm.
this option is not select any option.
Yes. Yeah.
Yeah, this three
Correct.
to power six and get it.
Correct. Correct. That is the approach actually. So basically, in a test paper, there are six questions, right? Okay. Suppose all of you have given the qualifier exam, right?
Yes, sir.
Okay.
Yes,
Suppose
sir.
I asked there are some 15 question and I ask I suppose just assume there are true false type questions. All 15 are true false type questions. Okay. Suppose I ask in how many ways you can attempt all the questions or all the questions of the qualifier exam. So how many ways you have to attempt that? Either you can select any option or you did not select any option, right? Yes or no?
Right, sir.
Yes, sir.
Right?
Yes.
So basically there are total six questions, right? So for first question, right? So it's activity 6.1. So for the first question, how many ways are there? There are three ways, right? First one, suppose they have selected the true, then I can select false, or I did not select any option. Can I do or not for question number one?
Yes, sir.
Right? Same for question number two. I will be having three ways, right? True, false, did not select, DS means did not select, correct? Same for question number three, yes or no? I have selected true, I have selected false, I did not select any option, yes or no? Same for
Sir.
question number five.
Yes, sir.
So for question number five and same question for the question number six. So basically, if you see for all of the questions, we will be having three ways, right? Since in the question paper there are total six questions, so it will be 3 into 3 into 3 into 3 into 3 into 3. That means 3
And to
raised
Three
the
power
power
power R.
six.
6. That means it's nothing but 729 ways.
729. Okay.
Got it?
Yes.
Okay. What about question number 2?
Question number 2 is 15 factorial by 4 factorial.
Okay, 15 factorial by 4 factorial by. Why not
11.
15 factorial divided by 11 factorial into 4 factorial?
Because it is not, we are not choosing anyone.
Okay.
It's a
Basically,
permutation.
it's a permutation, correct. So basically what question says? Okay, before going to that, let me tell you one concept. Basically, it's called how we are see. There are two concepts, right? First one is called combination, right? And permutation. Correct. So in combination, what we are doing in combination, order doesn't matter, correct?
Yes, sir.
Only we are doing the selection part. And in permutation, order matters. Yes or no? Right? So
Yes, sir.
basically, what we are doing in case of, okay, let me tell you one. So what do you mean by order matters, order doesn't matter? See, suppose I'm saying there are 10, or let's say 5 person in a room. Okay. And I'm saying I have to choose two people. I'm going to select two people. Okay. So in how many ways I can do? I can do 5C2. That is
2.
called I can choose a combination of two people out of 5. So here order
Yes, sir.
doesn't matter. Order doesn't matter means suppose I have selected
Combination.
P1 first and P2, or I have selected P2 first or P1, both are the same. See, at the end I have selected P1 and P2, right?
Right, sir.
Right. The formula for
Yes, sir.
this is nothing but for there is in general, suppose you have n items, in how many ways I can choose r items, that is NCR. So n factorial,
N
r
factorial
factorial,
upon
n minus
R
r
N
factorial
factorial.
minus R
into N minus
factorial.
R
Formula
factorial.
for combination. What do you mean by the permutation? Permutation here in order matters. Order matters, suppose out of 5 persons, right? I have to choose two person and then I have to give the position to them. Let's say one position is captain and another position is vice captain. Correct? Suppose
Yep.
suppose I have selected person P1 as a captain and then P2 as a vice captain, then person P2 as a captain and person P1 as a vice captain. So whether these two order are same or different.
Different, sir.
So in this case,
Different.
order matters. Correct?
Yes, sir.
So this is the basically key difference between permutation and combination. In combination, order doesn't matter, and in permutation, order matters. Okay.
Yes, sir.
Now, so
Yes.
if you see what we are doing in case of permutation, basically, what I have done, can I say I have selected two persons out of five people, and then I have arranged. Okay, can you tell me in how many ways I can arrange R distinct item?
2 ways, sir.
Two ways only. Tell me, I'm talking about R items. In how many ways you can arrange R items? R factorial, right?
R factorial, sir.
Yes, sir.
I'm talking about arrangement, correct? So now
Correct.
suppose I selected two person, right, out of five. Then in how many ways I can arrange these two person? Two
Two
factorial, correct? This is
Correct.
nothing but basically 5p2. Okay. So in permutation, what we are doing in backend, basically we are choosing or we are selecting the items and then we are arranging. If you are going to arrange, that means we are doing the ordering of the items, correct?
Sir, mute everyone.
Are you getting this point?
Yes, sir.
Yes, sir.
Okay. So basically, so what so in general, what I can say, n choose r into r factorial nothing but npr, right?
Yes, sir.
Yes, sir.
So what is here in case of here order matters, right?
Yes, sir.
Now, if you see the question, what professor is doing, professor is going to create a question paper of let's say 11 questions from a test bank of 15 questions. Now, if you see the question, in how many ways he can select and arrange the question. So first of all, in how many ways he can select the 11 questions?
15C11.
15
Now, in how many
C11.
ways he can arrange those 11?
11 factorial.
That is nothing but
15P11.
15p 11, right? Yes or no?
Right.
So if you will solve, right, if you solve, you are going to get the same thing, because if you see solve the left hand side, let me do it for this one. So you are going to get n factorial r factorial n minus r factorial, right, into
Right.
r factorial. So this is the nothing but npr. If you see r factorial will get cancelled out, so that's why we are getting npr as n factorial divided by n minus r factorial, right? So here it's we are going to get, it will be 15 factorial divided by 15 minus 11 factorial, which is nothing but 15 factorial divided by 4 factorial. Got it?
Sir, I have a doubt, sir, in this
Hmm?
same context. Sir, if we have 5 different textbooks, and if we have 5 different labels, and now if we are having to arrange it, first we
One second,
will
one second. I said, can you come in some peaceful place, because there are some background noise from your side. Again, it's coming. Might be mic issue.
yes, sir, maybe because
Yeah, can you recheck please? Because not able to hear properly. Okay. Just do let me know. Okay, I will solve that. Okay, what about question number 3? In how many
Sir,
ways?
sir,
Four.
how option B is correct in
That's why we
question
are
2?
discussing, right?
Okay, okay, sir. Okay.
What is?
I got it, sir.
Okay.
Yes,
What
sir.
about question
Yes.
number 3? In how many ways can 4 non-identical rings be worn on the 5 fingers?
Sir, it is a repeatable.
Sorry?
It is a repeatable. Repetition allows permutation.
No, I'm asking. Tell
But
me
it's
what
non-identical. Non-identical.
I'm talking. I'm telling. I'm asking about what was your approach for this question? In how many ways you can arrange 4 non-identical rings
5
for the 5.
factorial, sir.
Why not 4
Of-
factorial?
Because one figure may not have a ring, so we can take it as 5.
Or simply I can say some, let's say just assume some dummy ring, right?
Yeah.
Okay, can I say or not? So basically
Yes.
I have 4 non-identical rings, let's say R1, R2, R3, R4, or for the 5th finger, let's assume some dummy ring, right? Okay, can I assume or not? You can assume dummy ring or there is not any ring, something like that basically. Okay, or simply continue. Okay, continue. For the first ring, how many ways you have? 5.
5,
Yes, sir.
And for
5
the
twice.
second ring,
4,
4.
4.
4,
For the third ring,
3,
3,
for the
2,
fourth ring,
2.
2, 1.
120, right?
Sir,
Right.
sir,
Yep.
Yes.
sir, sorry to interrupt you, but
Mm-hmm.
these all these rings are not non-identical. So
Hmm.
every finger cannot have the R1 ring. Means it will not adjust in the R finger one in every ring one.
That's
It's
why it's
not
non-identical,
adjustable.
right?
Non-identical means it should be that
Different.
ring one will be adjustable in finger one only.
No, my dear friend, I
It's
think
like
it
that.
is the
They didn't
assumption is
specify
that
that, so we should take it
See,
as
see, see.
adjustable rings.
it's just the assumption
It's
that
just
everything will fit to everything.
yeah, it's not like the things.
Means
I mean, the one
I am
ring. Mhm.
I am little bit confused because of this word non-identical rings.
Yeah, see, non-identical
Why they
means it's.
have? I
See,
mean, sir,
listen to me. What I'm saying, non-identical means it's not like same. Okay, it's all are not as same. Suppose I'm saying, you have 4 identical keys. Okay, okay. That means
mm,
they will looks like the same, correct? But they are not the. Okay, non-identical means all are the different. Okay, it's not
mm,
like you are getting the confused. Okay, suppose I'm saying, see, identical means what? You can take example like, let's say you have black Honda City car of the same model. Let's say four are. So whether it will be identical or non-identical.
same color,
Same color, same model.
then it's identical.
Okay. Non-identical means suppose I have one Honda City or something, one let's say I-20 or something Verna and some another car.
Sir, you can just say we have one gold ring, one silver ring, one
Uh,
platinum, or something like that, right?
we can say, right? So non-identical means
Yeah.
you have from 4 different rings. Okay. No, those looks like not same. Okay.
Okay.
Yeah. So
So
what
one
about
question,
question?
sir.
Yes. Yeah.
The question is, uh, uh, I'm sorry, sir. Just give me 1 second. Sorry.
No problem. No problem. Okay. So can we move to the next part? Just do let me know once you got that. Okay.
Yes, sir.
Yes, sir. Actually, sir, the question is this, sir. So here they are saying that 4 identical rings to be worn on 5 fingers.
Hmm.
So we can also think of combinations like only one ring on one finger and remaining fingers, without ring kind of combinations also we may have to count, sir. No,
No, no, no. So basically, see, it's a just simple arrangement. Like suppose I have one ring, right?
correct.
In how many ways I can wear? How many choices I have to wear this ring? That's all. See, you can simply think. You have 4 people, right? And you have 5 places. That's all.
Mhm.
See, all 4 people will be non-identical, right? Different, right?
Mhm.
Correct.
Yeah.
And you suppose I'm saying you have some 5 different some some 5 places or 5 chairs are there, right? Then in how many ways I can arrange these 4 people on these 5 chairs? Got it?
Okay, sir.
Got it? Yeah.
Sir, now
But
it's much clear, sir.
Clear, right? Okay. So what about question number 4? In how many ways can 5 distinct book be arranged in 2 bookshelves?
I didn't get it, sir.
You did not get anybody who got the idea?
Sir, are the bookshelves identical or non-identical?
No, it's not about C. You can just
So
simply
it's
say.
5C2.
No, are you guessing or had you attempted? Not like you're just guessing.
No, sir.
Okay. See. Okay, let me tell you. Any one of you have done or not? If you are done, then you can go ahead. Okay, let me tell you. Here you have to think the cases. Okay, how I will take. So question is in how many ways can five distinct books be arranged in two bookshelves, right? So I have five distinct books, right? Right? And two bookshelves, right? Now tell me, can I make the cases like, suppose I am going to make a case one like, can I do five books? Can I arrange five books in first bookshelf and zero book in second?
Yes, sir.
So there are six possible ways like that, like
Correct,
5, 0, 4, 1.
correct. That is something we have to consider. So can I do this one? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now tell me, in how many ways you can arrange the five books in the first bookshelf?
5
6.
factorial.
5 factorial. And in how many ways you can arrange zero book or zero items in books second bookshelf?
1.
0 factorial, which is 1, right? So basically 5 factorial. Till this step, case 1 is clear.
Yes, sir.
Yes, sir.
Now, can I make the
Yes,
case
sir.
to like one book or sorry, let's say, yeah, let's say
First,
4 books. Okay. So let's make it like that. It will be easier for us. Okay. So 0 books in the first and 5 books in the second. So it will be 0 factorial into 5 factorial. At the end, I am going to get 5 factorial. So can I make one book in first bookshelf and remaining 4 books in the second? Yes or no?
Yes, sir.
Now tell me, in how many ways you can put or keep one book in the first bookshelf?
1 factorial. No, five ways.
5, because you have total 5 books. You can take any of the 5, right? Are you getting?
Yeah,
Yeah,
you can
correct.
pick any one
I
of the
can take
5 and put
I
it in the first shelf, and the
correct.
remaining
And
4 can be arranged in the second shelf.
second, and in how many ways you can arrange remaining 4? 4 factorial,
4P1, yeah.
right? That means nothing but again 5 factorial. Yes or no? So case 3 will be what? 2 books.
Sir, can you repeat it again, please?
Okay. So suppose I'm saying you have total 5 books, right? Tell me in how
Yeah.
many ways you can keep one book in the first bookshelf? 5, right?
5 ways, yeah.
See, you have anyway, you have 5 choices. You can
Okay.
take any of the 5, right?
Got
And
it.
remaining 4 in how many ways you can arrange in 4 factorial, right? Yes or no?
Yes, sir.
Suppose I'm going to arrange 2 books in the first bookshelf and remaining 3 books in the second. Now tell me in how many ways you can do? In how many ways you can do put 2 books in the first bookshelf?
5P2.
5
P2.
5P2.
or simply if I am talking about
5
counting in
factorial
terms of
divided by 2 factorial.
5.
if I talk about in terms of
5
counting, then
into
I
3
can
into
simply
4. 5
I
into
can
4
simply
into 3.
yeah. So I can okay. Let's go with the counting principle, right? It will be easier for us. In how many ways you can okay, so for the first book shelf, I will be having 5 choice for the first book. Yes or no? And for the second book, I will be having 4 choices, right?
Yes, sir.
Right? And remaining 3, in how many ways I can arrange? 3 factorial.
Yeah.
Correct? Everyone is getting? So it will be
yes,
what?
sir.
Again, it is 5 factorial. Right? So similarly, case 4 will be what? One book in, no, sorry, 3 books in first and 2 books in second, right? So in how many ways you can put this 3 books in the first? I can choose any of the 5,
5
then
into
4,
4 into 3.
then 3, then 2 factorial, right?
Right,
5
sir.
factorial, correct?
Mm.
Similarly, case 5 will be what? So 4 books in first and 1 book in the second book self, right? So now in how many ways you can put 4 books in the first? I can put any of the 5, then 4, then 3, then 2, and then 1, which is again 5 factorial.
Yes, sir.
Yes or no? Then
Yes, sir.
last case will be all 5 books are in first book self and 0 book in second book self, right? So that means what? It will be 5 factorial into 0 factorial, which is 5 factorial. So it will be, if you see, there are total 6 cases, right?
Right, sir.
Right? So total number of ways will be what? It will be
Yeah.
6 into 5 factorial, which is nothing but 6 factorial, which is 720. Got it?
Yes, sir.
Let's see the answers. Yeah, so 720,
Sir,
120.
can you
Yes,
solve this question from permutation formula?
you can do. This is something nothing but this is a permutation itself, right?
Sir, in each
Yes.
case we are not arranging in first bookshelf, sir. We are just finding the combination of first
No,
bookshelf.
no. Okay, okay. What you are doing this one?
Sir, in the first bookshelf we are finding the number of possibilities, and then
Okay, okay. Tell me. Okay, what we are doing now? Now, what you have done this one? 5 into 4 into 3 means what?
selecting the possible books from the 5 books.
Selecting or arranging? There is
Sir,
a
can I
difference.
use
No, sir, selecting is what we are doing here, sir.
Yes.
5 we are selecting first, and then we have 4, we can select 4, and then 3. Point here is after
That means, see, that
After that,
means
the second shelf, about the second shelf, sir, like we took 3 factorial, 2
Sir,
factorial, right? Why didn't we take 5 into 4? Something like that.
sir,
sorry.
Why didn't we take 5 into 4 into 3 factorial for the first bookshelf and then into 2 factorial for the second bookshelf?
Okay, see. If you are going to do 3 factor, right? That means what? Okay, let's do. You are saying 3 books in the first, right?
Yes.
And let's say 2 books in the second, right?
Yes.
Okay. So how many books do you have? 5. If you are saying 5C3, that means that's something you means, right? Yes or no?
Yes. Yes.
So if you solve 5C3, what it will give you? 5 factorial, 3 factorial, 2 factorial. That means 5 into 4 into 3. Something, right? Now, basically what we have to do, if I'm choosing these 3, that means we have to arrange these 3 also, right?
Yes, sir.
Correct or not? So what it will be? It's nothing but 5P3.
And then the second book, sir.
Okay, tell me what it will be? 5P3. 5
Five
into 4 into 3 into 2 factor, right? 2 factor will
Sir,
get
that's
cancelled
not
out.
the issue.
Hmm.
First, we for 3 books for arranging, we take 5p3. For the
Hmm.
second shelf, we gonna take 5p2, right? So why are we taking 2 factorial?
No, it's not
That's
like
the
in
issue.
no. It's not like in the book second book cell. There are only 5 places. These are just book cell. Okay, it's
Okay.
like this is the first book cell. This is the second book cell. Just consider in the first UO2, I'm going to arrange 3 books. In how many ways I can do? Either see, if you are talking about, I can simply do 5P3, or I have done simply 5 into 4 into 3. Both are the same,
Yeah,
right?
about the second bookshelf?
And what about second book cell? You have only 2 books, right? Remaining
So 2 factorial.
Yeah.
2 factorial.
Yes, sir.
Simple. That's something I have done, right?
Yes, sir.
Is this clear now?
Yes, sir. Clear.
Okay, yeah. So
Sir,
let's move.
yeah, but actually understanding the situation, I think we are far away from it, and because we at least I did not visualize that this many combinations are available for
Okay.
arranging the 5 books in just 2 shelves.
Yeah. No, basically, see, we have to. That's why we are see, this is something we have to think, because in this situation we are making mistakes. Basically,
Yeah.
whenever you are going to solve any kind of arrangement or something like that, okay, try to think all possible cases. Okay, it should be like there should not be any case which you are going to left, okay, or which you are going to miss. Okay, so
Okay.
that's I see. In sometimes we see I have five bookshelf and sorry, five books. I can simply arrange in five factorial ways, right? But that's not a case, right?
Yeah.
Okay, so basically we have to think. See, it's not any given condition, right? That means I can arrange in any way, right? I can put one book in the first, four book in the second, right? Something like that. But we have to arrange those five. Got it?
Sir,
Sir,
actually,
Hmm?
Sir,
yes,
can you hear me out once, please?
Yes.
For like for first bookshelf, we're gonna take example 3P2. I mean 5P3.
Hmm?
For second bookshelf, why can't we take 5P2?
That's the same
Why
thing.
are we taking 2 factorial? I didn't get it.
Once again, it's not like you have five places. See, you have
so
already, see, I have already chosen three books. See, what do you mean by 5P2? Basically, that means I have already chosen three books, right? And I
Yeah,
have arranged these three books in three factorial, which is nothing but 5P3.
yeah.
So you have already arranged three books, let's say book B1, B2, B3 in the first book. How many books do you have remaining now? Only two,
Okay, that's what it is. I got it now. Yes.
right?
Thank you so
So
much.
that
Yeah.
only two I can arrange in two factorial ways.
Okay,
Got
okay.
it?
Got
Yeah.
it, sir. Yeah. Thank you.
Essentially 2P2.
Yeah, 2P2 basically. Yeah.
Yeah.
If you talk about in formula.
Yeah.
No, not 2P2. 2P2. Yes, yes.
This
2P2.
2P2.
Correct. Ah, two. Sorry, sir. Two is 2P2.
Yeah. Two.
Yes.
I have two books and I can.
I have to arrange those two. Yeah, I can
Yeah.
do in 2P2. Yeah, correct. Correct. Okay. Any doubt in from activity 6.2?
No, sir.
Okay. All of
6.3.
you are aware this rearrangement or something, right?
Sir, please explain question number first.
The question, I think, had you attended the previous session yesterday, not yesterday, Friday session?
No, sir.
That's why. Just try to rewatch. Okay, I will tell you right now, but it's a suggestion. If you're coming in the session, right? So it's good to first of all to watch the lectures video and some. Okay, try to attend the live session. It will be easier, good for you. Okay. So basically, there is one. Okay. So in how many ways? Any one of you wants to explain the first question? Rearrangement.
yes, sir.
A number of letters by number of repeated letters.
Number of letters
Yeah.
divided with. Okay, so there is one concept basically. Suppose I have something. Let's say I'm saying. Let's say I have word data. Okay. Now, in how many ways I
4
can?
by 2.
Yeah. In how many ways I can rearrange the letters? So what do you mean by rearrangement? So basically, what are the distinct? So there are concepts. What are the distinct? How many distinct letters are there? One, two,
Two.
three, four. Yes or no? Total four letters are there, right? Distinct means just consider A1, A2. Total 4 factorial are there. Yes or no?
Yes, sir.
And how many
Yes.
similar are there? Only
Two.
2. See, similar is A, but it is occurring 2 times. So there is one concept. It will be, you have to divide by the 2 factorial ways. So if you see, you are going to get total 12 ways, right? Yes or no? So basically, what we are doing, in how many ways you can rearrange? Rearrange this. Let's say I'm saying D, A1, T, A2. If you see D, A2, T, A1. So just consider. So now, will this 2 will be same, right? At the end,
Yes, sir.
right? So that's why we are going to divide. Okay, basically. So that's concept called just see total number of letters divided by, suppose in that word, let's say one letter is repeating. Let's say, see there see this is one kind of letter, right? Suppose there are some three kinds or R kinds. R kind is, let's say, in if you see in the programming, so M is one kind, right? This is repeating. Yes or no? What
Yes,
else?
sir.
G is another kind of letter which is repeating,
Yes, sir.
right?
And R.
So another, yeah. So basically, suppose P1 is first kind of letter. There are first kind of letter which is in P1, P2 second. So basically, so we have to divide P1 factorial into P2 factorial up to, let's say, Pk. Let's say there are some kth kind of variables, right? Something like that. So if you see in the programming, how many total letters are? 3, 3, 6, 11, right?
Yes, sir.
So in programming, if you see, okay, double M should be right. So if you see total 11 letters are there, right? And divide by what are the repeaters? 2 factorial
M
into,
and G.
and G is repeating 2 times, right? Basically.
R.
So, yeah. So
R.
R is,
R was 2 times.
R is also 2 times.
Yes,
Yes,
sir.
yes. R is also 2 times. So it will be 2 factorial. So just solve it, you will get the answer. Okay. Okay. Is there any doubt in any question of this activity?
Question number 4 and 5.
Question number 4 and 5.
Yeah, and question number 2 also.
Question 2.
Question 2. In how many ways can the letters, I mean, except 3, you ask everyone. Okay. No problem. So question number 2 says, in how many ways can the letters of the word scissors be arranged so that all the S are together? Okay. So for the letter scissors, if you see, all S should be together, right?
Yes. So
Okay.
there are 4 S and others are 1. So what I have approached that we have a distinct.
No. See, it's not like
No,
we
we
have
should.
to.
You should think all SS as one.
Yes. Basically,
Yes,
it's not like
that's
we are
why.
going to see 1, 2, 3, 4, right? Now,
Yes, those are together we have
let's
to
say
arrange.
ICOR, right?
Yes.
Okay. So these 4 are distinct.
Yes.
And these are the 4. These are the, I can consider as a one unit.
Yes.
Right. So how many distinct you have?
5 distinct.
5 distinct. Now, if I have 5 distinct thing, in how many ways you can arrange?
8 P 5. 8
Why?
P 5.
Why 8? If you see the question, we are just asking in how many ways can the letters of word be arranged. We are not going to do the rearrangement the things. Basically, we are doing. If you see in how many ways, now you can suppose I'm saying these are the 5 distinct things. In how many ways you can arrange?
5 factorial.
5 factorial.
Which is 120.
Got it? You have 5 distinct things. You have to just arrange. It's not like about some place and all, right?
Sir, this question is different from the first question, sir. This question is different from the first question, where we have handled the repetitions differently. Find the number of rearrangements of the letters in the word.
Yes.
Okay, in how many ways can the letters of the word be rearranged? Just the English difference, but so that all the S's are together. Oh, all the S's are together.
Yes. So basically, it's not. See, if you see the question, the data example, right?
Sir, if they, no, sir, 1 second. If they don't say that, if all S's are together, then
it's the same
as the first one, right, sir?
Okay. Let me clarify. Okay, suppose I'm saying I have word data, right? Okay. Suppose in what will be the total number of ways? It will be 4 factorial divided by 2 factorial.
Correct, sir.
Which is nothing but 4 into 3 into 2 factorial. That means total 12 ways, right? Okay. Why we are dividing by 2 factorial and all? If you see, let's consider as A1 and A2.
Correct.
Okay. So if you see DA1, TA2, or suppose I'm saying DA2, TA1, that means these both will be same
data
at the end.
Correct.
Similarly, if you suppose I'm saying AD, TA, or let's say A2 or A2, D, TA1, at the end it will be same.
Yeah, correct.
That's why we are going to divide by 2 factorial, something like that, right? So basically, what we are doing, we are rearranging. Now, if suppose I'm in how many ways I can arrange the letters of the word data when A are together. That means I'm saying A are together and I have D or T, right? In
Yeah.
how many ways you can do?
So AA can need to be treated as only one word, one letter.
One
sorry.
word, right?
One
Because
letter,
it will
yeah.
be, yeah, so it will be total 6. How? It will be, let's say, I can see.
I
First
have
of all,
it's like having only 3 letters with me.
correct, correct. So I can do one these things, right?
Yeah, yeah.
Correct.
Yeah.
Or else what I can do like this.
Yeah.
Or else what I can do? Sorry.
Yeah, understood, sir. So main difference is in the
Correct,
second
correct.
question they said that all S's are together.
Together, yeah.
Yeah.
So
Otherwise,
Sir, you mean
we follow the same technique, right, sir? Factorial of the total number of letters
yeah,
by
yeah, it will
the
be,
number
see,
of repetitions.
question will be, we are going to rearrange the word. That's all, right? How we can rearrange? We can just reshuffle the things and all, something like that. Okay. So there will, if you see, there will be total 6 cases, right? I can reverse these things, right? Something A T D, right?
Yeah.
Or T A D and T D A. I think these are the total 6 possible cases.
Yeah.
And in how many ways you can do the same thing? Three different things. 3 factorial.
Yeah.
Which is 6 ways. Got it? What are those 6 ways? If all A are together, all A are together, right?
Yes, sir.
Yes, clear?
so in this question, instead of in how many ways, if it is given like how the word can be
See,
rearranged,
basically,
then it will
suppose
be 8
question is
factorial
in
by
how
4
many
factorial.
ways, see, in how many ways we can rearrange the letters of the word. That's all.
Okay.
Okay. Yeah. It's clear now, right, everyone?
Yes.
Okay. What about question number 3? 7 people are going to sit it at a round table. How many ways? How many different ways can this be done?
We can apply the
N
different
minus 1
formula.
factorial.
N
Okay,
minus 1
anyone?
factorial.
Why we are doing n minus 1 factorial first of all?
That is a circular permutation.
In the
It's a
lecture,
circular permutation. That's the question I'm
shows.
asking. Why we are dividing by the, why we are doing n minus 1 factorial in circular permutation?
Sir, first we are arranging the first person, and then the remaining persons around him. We have to first person can be arranged anywhere on the circle.
Okay,
Then
okay. First of all, let me ask you. Suppose I
It's
have 4
about the
people.
direction, sir.
Okay. Suppose I'm asking. I have 4 people, right? In how many ways you can arrange 4 people in a linear way? In a linear?
4 factorial.
4 factor, right? Now, if you see, what
Yes,
is the arrangement
correct.
I have? I have A, B, C, and D, right? Yes or no?
Yes.
Suppose I'm doing arrangement like this: A, B, C, D. Again, I will be having same arrangement. Yes or no?
Yes, sir.
Suppose I have arranged like this: A, B, C. Again, I will be having same arrangement.
Yes, sir.
Yes, sir.
Suppose I done the arrangement like this: A, B, C, D. Right? These 4 are going to be the same, right?
Yes, sir.
So can I divide by the 4?
Yes, sir.
So it will be
Yes, sir.
4 into 4 or 3. Basically 4. It will be 4 into 3 factorial. 4 will get cancel out. So we will be having 3 factorial. So in case of in general, when we have n people and we have to arrange on a circular way, when clockwise and anti-clockwise are different, then it will be n minus 1 factorial, right? This is nothing but 4 minus 1 factorial. Got it? Why we are how we got the n minus 1 factorial?
No,
Got it,
Yes.
sir.
no, sir. 4 into 3 factorial. How? That is one question, sir. So even before that, my question is, sir, you're saying A, B, C, D, and if you rotate them by 90 degrees, the arrangement is still same.
No, arrangement is okay. On a circular permutation, if you
Correct.
see.
Yes, sir. On a circle, if you if you rotate them in by 90 degrees, the arrangement is still same because everybody is with respect to the other person is in the same positions.
Correct. Neighbors are same, right?
Yeah, but position should we think from the other person perspective, sir, or with respect to the ground or the chair?
No, it's not like that. See. It's a simply, if you see, neighbors are going to be same in any way. See, whether I'm going to start from here
Correct.
or here or see, suppose I'm going to start person A here, right? Then I'm going to get what kind of arrangement? A, B, C, D.
Yeah.
Suppose I started the arrangement, let's say this red one from here. Okay. First A is going to sit here, then B is going to sit here, then C is going to sit here, D. Again, I'm going to get the A, B, C, D.
Correct, sir. But see, for example, in the linear, we are number. Let's say we are giving a number to the chairs 1, 2, 3, 4, and persons A, B, C, D.
It's not. See, chairs will be same as per the.
It's better to say anti-clockwise and clockwise. Are, if they both are same, we're gonna take n-1 factorial. If they are different, we're gonna take
then it's n-1 factorial. Basically, it's depends on the Prasad.
For same n-1 factorial upon 2.
See, for anti-clockwise.
Yeah, for same. I missed the flow.
For clockwise, anti-clockwise, when I say, then we are going to consider as a n-1 factorial by 2, and if it's not same, n-1 factorial. Okay, let me draw that one. It will be easier for you. Okay, so basically, suppose I have this arrangement, right? Suppose A is here, B is here, C is here, D is here. This is the different one, right?
Yeah.
How we can arrange totally? So I can arrange A, C, right? Then D, then B. Yes or no?
Yeah.
I can suppose A is here. These are the total possible different one we are going to achieve. Right? So when you will be having 4 people, correct? This one I can do. This is the different or not? This is B. Right? So A, B, C, D. Correct or not? So A, C, D, D. Right? So if you see, these are the total 6 different ways, right? I can arrange the 4 different people on a circular permutation when clockwise and anti-clockwise are different. Yes or no?
Yes, sir.
Is it clear?
Yes, sir. Yes, sir.
Now, when clockwise and anti-clockwise will be same, then?
Then divide by 2, sir. n-1 divided by 2.
n-1 factorial divided by?
n-1 factorial divided by 2.
Okay. So we will be having total 3 ways, right? So what do you mean by clockwise and anti-clockwise are same? So that means in that case, let me draw. Suppose I have A, right? You will have, so let's say B, then C, then D, right? So if you see, in this case, A, B, C, D, right?
Yeah.
Right?
Yes, sir.
So basically, what do you mean by clockwise and anti-clockwise? Same. Suppose okay, if you see A, B, C, D, or here if you go see here if you go clockwise, right? I'm just telling the meaning of clockwise and what do you mean by same. So if you see, if I'm going to get anti-clockwise, then we have to see the case where both are the same. So if you see here, both arrangement are same, right? A, B, C, D, A, B, C, D, right?
Right, sir.
Right? So this will be same, right? If you see here, AC, DB, right? Sorry, AC, DB, right? If you see, if you go anti-clockwise, then again you are going to AC, DB. This will be same. Same
Yes,
for
sir.
here. So that's why these both cases will be same in case of anti-clockwise. Okay. If we have arrangement like this, when clockwise and anti-clockwise are going to be same, then we will be having n-1 factorial divided by 2. So here it will be 6 by 2, which is 3. Or what is this 6? This is 6, nothing but 3 factorial. And what is this 3 factorial? 4 minus 1 factorial divided. Right? In case of clockwise and anti-clockwise are same. Okay. So if you see, I will be see, we have here total 7 people, right? And in how many ways we can arrange these 7 people on a round table? In case of person, tell me, clockwise and anti-clockwise will be same?
No, sir.
No, right? Are you getting? Everyone is getting the concept, right?
Yes, sir.
Okay. So it will be to arrange the 7 people on a circular table. In how many ways I can do?
n-1 factorial, 7 minus
so that
1
means
factorial,
7 minus
6
1
factorial.
factorial, that is 6 factorial, which is nothing but 720 ways, right? by the formula. Is it okay?
Yes, sir.
Sir,
Now, yes,
sir,
yeah,
one
yeah.
question, sir.
Mhm.
So here they have not mentioned whether clockwise and anti-clockwise are same or not. So what are the defaults that we should take,
No,
sir?
not go with the default. Okay, suppose, okay, you have to think. Suppose you have 7 different people. If you are going to arrange 7 people, will the clockwise anti-clockwise will be same in case of people, person? See, clockwise anti-clockwise means what? Mirror image should be same.
Okay.
Okay, mirror image should be same. Okay, so okay, let's come to the next question. It will give you idea. So suppose find the number of ways in which 8 beads can be arranged in a to form a necklace. Suppose you have some 8 beads. If you see the mirror image of necklace, again it will look like the same, right?
n minus factorial by 2.
Are you getting?
Yeah.
Okay, so clockwise anti-clockwise same are means if you are here, see. Suppose if you are here at this point, right? At this point,
Here, what
then
is
you
B?
can see the same arrangement A B C D. If you see here, if you are here, then if you are watching like this, you should get the same arrangement. That is the meaning of clockwise and anti-clockwise are same. Okay. So if you see the in case of beads, if you see the mirror image, then it looks like same, right? But in case of person, it will be different. Okay.
Yes, sir.
Is this clear to us now, right?
Yeah, I mean, so there we should not take it as a B1, B2, B3 before like that, sir.
B1. No,
Like
see,
beads.
even though it's a beads, right? See, suppose this is the necklace, okay?
Right, sir.
Suppose let's say I have some 8 beads,
Uh,
3, 4, 5, 6, 7, or something like that. Some arrangement, some 8 beads are something like that. Okay. If you
yeah.
see the mirror image, it will look. Suppose you are here,
Uh,
necklace look like same.
yeah.
Okay.
Uh,
See the just try to imagine the mirror image, right? At
uh,
the end you are going. It will look same. If suppose there are some person, okay. Suppose he is Syam, and this is Ram. Suppose this is Mohan. Okay. Suppose this is Suresh, something like this is let's say Suman. Okay. And you are here. Okay. Suppose I think Prasad, correct me
yeah.
if I'm not right. Suppose
Yeah.
you are here. If you are at this point, can you tell me now whether you will be able to see the clockwise anti-clockwise same?
No, sir.
No, on the right side, I see one person and
That another one, right? In the case of person, here clockwise anti-clockwise is not same, right? Got the idea?
yeah.
Okay, yeah. So what about question number 5 is just a calculation part. Should I do or it's okay?
So in summary,
Sir,
if we
sir,
are
do,
talking
sir.
about the people, then both clockwise and anti-clockwise, we need to take them differently.
Different,
But
yeah,
in
it's a
case of
different.
objects, we can take them as same.
But not always. You have to think whether it's whether mirror image will be same or not.
Okay.
Okay. Suppose I'm saying there are some 7 key. Okay. Suppose I'm just creating a scenario. Okay.
Yeah.
Suppose you have some in a some one lock. There are some 7 keys. Okay. All are different types of key of a flat. Different. Some direct lock, something like that. Okay. Some
Right.
different. Now, if you going to do in some keychain, circular keychain, in how many ways you can do? All are different, distinct.
Okay.
Suppose one key is like this, something, okay, something like
Yeah.
this. Another is some another
Essentially,
design,
7 keys belong to 7 different flats, let's say, sir.
something.
Right.
In how many ways you can arrange?
7 minus 1 factorial. Means it's again 720. 6 factorial means 720.
Let's not go the calculus part. They are just trying to understand the concept.
Yeah.
Prasad,
Yes, sir.
tell me
Yes.
whether
sir.
it will be 7 minus 1 factorial or 7 minus 1 factorial by 2.
It will be 7 minus 1 factorial, sir.
Okay. Suppose I'm saying all the keys are
All
identical, all of the same kind. I mean, same size. It's very identical. I mean, same size, same color, something like that. Now,
Right.
if you going to put
Then
all
we
in a
use 7 minus 1 factorial by 2.
then we can use. So because if you put and you are here, or then all the keys look like same, right? Right? Now then mirror image will be same, right? Got it? Got the difference? basically. So it's
Yes.
not like always about it's a object then 7 minus 1 sorry n minus 1 factorial by 2. Basic thing is just think whether the mirror image will be same or different. Okay,
Okay. Okay,
got
sir.
it? Yeah. So question number 5, I think just a calculation part. Should I do or it's okay for everyone?
Could
No,
you
sir.
please
Sir, please do, sir.
do it?
Sir,
I think
I
you
have
you
doubt
haven't
in.
not tried, I think.
I have
So this,
tried.
Huh?
So,
Sir,
so this
tried,
is
sir, but
simply
no answer.
this is simply solving the equation, sir.
Yeah, just solving
yes,
the
sir.
equation. Okay, let me do it. You are asking
It's
n plus 1 p2 equal to 4 into n p1. And this kind of simple calculation, I think you guys can do easily, right?
Sir, I am stuck with last point.
Which point in
Last
this
point.
equation? In this question.
Yes, sir.
Okay, I'm going to solve. Okay, what is the formula for NPR? Basically, n factorial divided by n minus r factorial, right? So here what you can do, n plus 1 factorial divided by n plus 1 minus 2 factorial or not?
Yes, sir.
4 into n factorial divided by n minus,
1 factorial.
right? I'm just using the formula. That's all. I'm not doing any different thing. Okay. So n plus 1 factorial, what I can write? I can write n plus 1 into n factorial. Yes or no? I
How,
have 5
sir?
How,
factorial. I
sir?
can simply write 5 into 4 factorial, right?
Yes, sir.
Right? What about denominator? Denominator is going to be n minus 1 factorial, which is nothing but 4 into n factorial divided by n minus. This n minus 1 will get cancelled out. This n will get cancelled out. What we have? N plus 1 equal to 4. N is 3. Is this answer? Let me check the answer.
Yes, sir, it's the answer.
Yeah, and
3.
n is 3.
Sir, can you
Right?
explain how to write n plus 1 factorial is equal to...
Sir, in the
Okay.
third step, sir, n
Huh?
plus 1 into n factorial, how you write it?
Okay, did you get this idea?
No, sir.
I think you guys have not attended the previous session. Okay, no problem. Let me tell you. Okay, suppose, okay, how will you write what do you mean by the factorial first of all? Suppose I'm going to write 2 factorial. That means what? 2
2
into
into
1,
1.
3 factorial,
3 into 2 into
3
1.
into 2 into
4
1.
factorial,
4 into 3 into 2 into 1.
5 factorial,
5 into 4 into 3 into 2 into 1.
right? Now tell
Right.
me, if this is 5 factorial, so can I write this 4 into 3 into 2, 1 as a 4 factorial or not?
Yes, sir.
Yes.
So that means simply I can write down 5 into 4 factorial to 5 factorial.
Yes, sir.
Instead of 5, I suppose n plus 1 factorial, then I can write n plus 1 into n factorial. Just put n as a 4. Then you will get 5 factorial equal to 5 into 4 factorial or not?
Yes, sir.
Got it?
Yes, sir.
Clear? Clear, right? Am I- Or any doubt?
Yes, sir.
Okay.
Clear.
Huh.
6.3, question number 7, sir.
Okay. Question number?
7, the last one.
Okay, I will come to that. Before that, anyone in any question you heard out? What about first question?
So question number 3rd.
What about first question? First question is clear to everyone?
Yes, sir.
Okay. So it is asking about out of 6 men and 8 women, I have to form a committee of 3 men and 5 women. In how many ways I can form the committee? So basically, I have to do, basically, I have to select the 3 out of 5, sorry, 6, and I have to select the 5 out of 8. Correct or not? Is it okay? See, you have to form the group of 3 men out of 6. So basically, I have to select first of all 6 out of 6, 3, right? So in how many ways I can select 3% out of 6? 6, 3, 6C3, right? And in how many ways you can select 5 women out of 8? Simply 8C5. Basically, you have to
Yes,
form
sir.
the committee. That means it will be basically 6C3 into 8C5. That's all, right? Due to 5. Is this clear? We are not going to arrange, or there is not any order and all, right? We have to just select, do the selection, right?
Yes, sir.
For the question number 2, we have to find the number of subset, right? Of the set. In how many ways I can choose 5 elements,
Here also order does not matter.
right? I have to just make the subset. So it will be 10C5, right?
Yes, sir.
Question number 3. Okay. So what do you mean by, I mean, in this question number 3, if you see, we got just, I mean, suppose you got 3 free tickets. Okay. On the purchase of 1 ticket that allowed 3 people along with you for a movie, correct? Suppose if you have 6 friends who wants to come along, how many different groups of 3 friends you could have? It's a simple, right? It's you have 6 people, 6 group of 6 friends, and you want to allow only 3. In how many ways you can choose 3 friends out of 6?
6C3 only, sir.
63. That's all, right?
Yeah.
So just find out the value of 63. Okay. Question number 4. It says 2 raised power 10. Basically, this is adding the coefficient, right? It will give you 2 raised power 10.
Sir,
Yes.
how to solve this, sir?
See, it's just basically, if you see, if you go ahead, these are basically called the binomial coefficient, or else you can just simply find out the value that and you can compare with it. Right? See, there is one. See, you know that formula NCR plus N minus one CR minus something
Yes,
like
sir.
that.
Yes, sir.
You can use that one
Yes, sir.
also. Okay. What about question number 5? Question number 5 is
So
okay.
it is a simple straight calculation and adding all of them. That's it, right, sir?
Ha,
No
ha,
other,
ha.
I mean, no other
See,
formula.
okay, if you go ahead right forward, then it's a called basically binomial coefficient. Okay. So if I will have some NC1 plus NC2 plus NC3
So we
plus,
use the formula for all the condition and then we
basically it's
add it.
there is one binomial coefficient. Suppose I have NC0, NC1 plus NC2 plus up to N choose N, it will give you 2 raised power N basically. Okay, or else you can cross verify with the options. Okay, it's just to giving you idea basically this formula.
Okay, sir.
Okay, yeah.
So
What about question
we
number
should start with 0. Okay.
0? It should start with 0.
Okay.
What about question number 5? Question number 5 is okay. Just need to
Yes, sir.
calculate, right?
Yes, sir. It's easy.
Question
Yes.
number 6. 15 points are chosen in the plane so that no 3 of them are collinear. How many triangles do they determine? How many triangles you can form?
15C3 and 15C12.
Basically, if I have 3 points, right? In how many ways, how many lines I can find by considering these 3 points?
3 lines.
3 lines.
3 lines.
3. Basically, so basically, if you see, so you have total 15 points, right? To make them, I mean, to make a triangle like this, to make a triangle like this, how many points do I need to choose?
3 points.
3 points, which I
3
in how
points.
many ways I can choose?
15C3.
Right? And you know n choose r is equal to n choose n minus r.
Yep.
Both are the same or not?
Yes, sir.
Same,
See,
sir.
if you see n choose r, that means what? N factorial divided by r factorial into n minus r factorial, right? And
Yes, sir.
n choose n minus r means what? N factorial divided by n minus r factorial into n minus n r factorial, right? And then what we are going to, we got the same value, right? These two are same. Yes or no?
Yes, sir. Yes,
So
sir.
that means
Yes, sir.
15C3 will be 15C, 15 minus 3, that means 15C12. Okay.
Yes, sir.
Yes, no, right? So 15C12 and 15C3 should be the correct answer. Got it? Clear for everyone? Any doubt?
Clear, sir.
Clear? Okay. What about question number 4? Sorry, 7. I think someone asked this question, right? If I'm not wrong.
Yes, sir.
Okay. A box contains 5 red, 4 white, and 2 blue balls. 3 balls are drawn at random. Find the number of days. Selecting balls of the. Okay. How did you have done this one? I think you're done 5.9, 11C3, right?
I don't exactly remember, sir, but I got 195. It's been
195.
days I done that.
Okay, what is the answer then? You got 195, but answer should not be. Okay, anyone
Answer
had
is
a
40.
okay.
Sir,
How did
what
you
did you
done
tell?
this?
11C3.
Yeah. So 11C3 should be correct answer.
No,
Yes,
sir.
sir.
Actually, we have to select one from red, one from white, one from
It's
blue.
not like, see, in 11C3, basically 5 red, 4 white, and 2 blue. So there are 5 red, 4 white, and 2 blue balls, right?
2 blue. Yes, sir.
If you are going to select only 11, sorry, 3 balls, right? That means all balls can be of the same color, right? One ball, let's say red, two are white, two white, one black, something like this. It's not a condition. Condition is all the balls should be the different color. Means we are going to select 3 balls. One should be red, one should be white, and one should be black.
Blue.
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 Blue. It's blue or black. Whatever.
Blue,
Blue, right?
sir. It's
So,
blue.
okay. In how many ways you can choose one red ball?
5C1.
In how many
5C1.
ways I can choose one white
4C1.
ball?
4C1.
4C1.
And how many I can choose?
Yeah.
That
40.
means 40, right?
2C1.
40.
Got it?
I remember how I done it. I took
Yeah.
like all the balls, like what do you say?
11C3.
Yes, sir.
Okay,
Yes, sir.
but that's not a, see, in this case, what is happening?
In
It
that
can be
I
right.
subtracted things.
Huh?
Like I subtracted again.
But there
All
will be lots
the
of
red
cases.
balls.
See, there will be lots of cases. Means you have to subtract this, you have to subtract all these things, you have to subtract, all these things, you have to subtract R, R, B, R, R, W. No, this is something tedious task, right?
Yes, sir.
Got it? Yeah.
Yes, sir.
Yeah.
Thank you.
Clear now? Now it's clear, right? Okay, let's come to the last activity.
6.4 first answer.
No problem. So there are 6 consonant, 4 vowel. In how many ways? Words of 3 consonant, 2. I think. Okay, how you have done? Simply 6C3 into 4C2, right? Yes or no?
I got like 1440, but the answer is 14400.
Okay, 1440. How did you get 6C3 into 4C2, right?
Yeah.
Correct. But
Yes, sir.
any one of you have done this one or not? So basically, if you see,
I
see,
did
see.
not done this activity.
Okay, no problem. So I have 6 consonant and 4 vowels, right? So
Consonant vowels.
I have 6 consonant, right? And 4 vowels. I have to form a word, 3 consonant and 2 vowels. Correct? So in
Yes,
how
sir.
many I can choose 3 consonant, 6C3,
6.
and 2 vowels, 4C2. But
Yes, sir. 4C2.
see, what you have to do, I have to form a
P.
word, right? So that means to form a word, I have to arrange those letters or not.
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Correct. So see, suppose I'm saying you selected 3 consonant, let's say B, C, D, right? And any 2 vowel, let's say A, E. But that is not a word. To form a word, you have to arrange, right? Correct. In
Yes,
how
sir.
many ways you can arrange those 5 letters? Tell me, in how many ways you can arrange 5 letters?
5 factorial.
It's a 5 factorial. You have to just multiply with the 5 factorial. Got it?
Say, am I audible?
Yeah. So if you see here, it will be 6 factorial, 3 factorial, 3 factorial if I am going to apply the formula into 4 factorial, 2 factorial, 2 factorial into 5 factorial, right? So basically you will solve it will be 6, 5, 4 into 3 factorial. So 3 factorial into 3 factorial, 1 3 factorial will get cancelled out, 3 factorial it will be
6.
and 4 into 3 into 2 factorial, 2 factorial into 2
12.
factorial. So this will get cancelled out 2. So this is the 5 factorial. So basically if you see, this is nothing but 40, right?
40, yeah.
And into 120. 40.
Sir, 40 into 5.
Yeah, this 3 is also there. So it's a 40 into 3
It's a
into,
40 into.
so 120
Sir,
into
20 into
120, right? So it will be 14400. Got it?
144.
See, key thing is you to notice here, you are going to form a word. You are not, see, you are not stopping your procedure only after the selection of the letters, right? Clear?
Yes, sir.
Okay. Any other doubt? Question number 2, question number 3, question number 4. Anybody?
No, sir.
Sir, I have a doubt, sir, but it's conceptual, sir. Can
Okay, I will come to that one. Question number 2 is okay for everyone? Okay, you tell me. There are 40 men and 15 women in a party. Each man, they can do handshake with all the men, and each woman, they can handshake with all the women only. So in how many? What will be the maximum number of handshake? But each group of 2 persons will have one handshake. Means basically, suppose 2 person, men 1, man 2, it will be considered as one handshake. So to make a one handshake, how may okay? What the required thing? 2 person, right? Yes or no?
Yes, sir.
You okay? How many people you have? Men only 40.
40 men
So
and
that means to
15.
make a
15 women.
to make a single handshake, what is the required thing? You need to
40
select
C2.
2 people.
Yes, sir.
You need to select 2 people. That means I can do 40 C2
Yes, sir, 40 C2.
plus 15 C2, right?
So why plus?
We have to
Yes, sir.
count the number. Okay.
Okay, sir.
We have to
Okay, sir.
count the total number of handshakes. Now come to the question number 3. How many 2 digits numbers can be formed using this digits if repetition is not allowed? Tell me. You have 5 digits, 83529, and you have to form a 2-digit number without repetition.
20, sir.
5 into 4,
Oh,
right?
yeah.
See,
Yes, sir.
we have total 5 digits. To form a 2-digit, then for the first digit, I will be having 5 option, and then for the
Factorial
second
will be
digit, I
4
will be
option.
having 4, right? This is
4
nothing.
option.
Got it? Okay, what about question number 4?
So I think 30.
Sorry?
30.
30. How?
6P2.
Sir, 6P2.
Basically, if you see, you have total 6 entries, right? And we have to select the first and second place prizes. And in how many ways I can do simply? 6 into, correct or not?
Yes, sir. 6 into 5.
Okay. Yeah, someone was asking any concept. I think we have done the activity question. Yeah. What is the doubt? What is your doubt, please?
Sir, if we have, let's say if we have 4 different textbooks, sir,
Hmm.
and then we are
Repeat
having 7
question number 4,
different
sir.
4 different textbooks.
textbooks and 7 different labels for the textbooks that
Okay.
we can apply. 7 different labels.
Labels means what?
Sir, something, sir, 7 different marks or 7 different.
Okay.
labels that we can apply for the 4 different textbooks, then sir, here is the repetition allowed? I mean, sir, can we do we have to arrange it again after selecting? Do we have to arrange it again?
No, these are the 7 different labels, right? And these are the 4 different textbooks. You have to
Yes.
apply the labels on textbook, right?
Yes, sir. So how
First of
many?
all, let me tell you, this is the EMQ question, right? Or first question of the week 5
Yes,
graded
sir. It's
assignment.
similar to EMQ question, like
It's the first question of week 5
numbers,
graded assignment,
and
right?
numbers.
Am I correct?
Yes, sir.
There are some textbook, Vinod has to something, and some and registers and some cover papers.
Yes, sir.
Yes, sir.
9 cover papers.
Okay, so please do it on your own. Okay,
Yes,
you have to
sir.
think. I can't tell. Okay, so it's the request. Don't ask the question like this. Okay, is this clear now? Okay, so since due date is not over, so please try on your own. Just think you have some different cover papers for the first book. How many options will we having? Then second. So like this, just think. Okay, is this clear?
Yes.
Okay, yeah. Thanks. Any other doubt?
Sir, I am
Anyone?
doubting
Sir,
tutorial 4.
tutorial 2.
That in week 5.
Tutorial 2 week 5.
No, week 6 tutorial 2.
What is the tutorial? Let me see. What is the question? 10 dishes. Okay. Had you gone through the solution?
Yes, sir. I have doubts in that.
In the solution itself.
Yeah,
Let
I
me
didn't
see
get that.
Let me see the question. There are some 5. See the questions. What is the question? There are 5.
There are 5 special dishes in a collection of 10 dishes. How many ways can we serve 7 dishes in a sequence such that at least 3 special dishes are served, and special dishes are served consecutively?
Okay. So, where is your doubt?
The way they solved it.
Okay. Let me do the question. So there are basically 5 special dishes, right?
Special dishes, yeah.
So out of 10 dishes, so that means 5 will be
10
ordinary,
normal
right?
dishes, yeah.
So so can I consider it as 1 special dishes? Okay. Let's consider. That means 5 will be ordinary.
Ordinary. Yes, sir.
Okay. Now, in how many ways can
They are
we?
going to serve 7 dishes.
Okay, we can serve the 7 dishes in a sequence such that at least 3 special dishes are served, right?
Served
So what do you mean by at
consecutively,
least 3? It
3
can
or
be
more.
more than 3, right? Right? And at least
Yes.
3 served and are served consecutively. Okay. Got it. Okay, let me. What do you mean by consecutively? That means suppose S1, S2, S3 together, right?
Yes, sir.
Okay. So see, there will be cases. See, there are total. Basically, we have to sort for the. Basically we have total 5 different kind of special cases. Okay, special dishes. So case 1 will be like at least 3, right? So what do you mean by at least 3 special dishes?
3 special dishes and 4 normal dishes.
Right. So that means 3 special dishes
4 ordinary dishes.
and 4 ordinary.
Yeah.
Right. Now what do you mean by? So basically we have to do. If you see. Okay. See, tell me. That means S1, S2, S3, right? And O1, O2, O3, O4, right? That is the something we are going to consider here, right?
Yes, sir.
Yes or no?
Yes, sir.
Now tell me one thing. So this means what? This is going to something I can consider as a 1 entry,
Yes, sir.
and this
Another
is
of
something I
4,
can
which
consider
is
as a
total
4
5.
entry, right? Can I do it or not?
Yes, sir.
So basically, if you see, in how many ways you can choose this 3? 5C3.
5C3, yeah.
Right? And in how many ways? I can rearrange these 3 among themselves. Yes or no?
Yes,
This
sir.
S1, S2, S3. In how many ways I can arrange?
3 factorial.
Now, come to the next part, this one. In how many ways I can take the 4 ordinary?
5C4.
That's all right. That's all 5C4, right? Can you tell me, now I have 5 different entry, right?
Yes, sir.
In how many ways I can arrange these 5 entry? See, this 5C3 into 3 factor is only for special dishes. Okay?
Yes, sir.
Now I'm going to arrange 1, 2, 3, 4, these 4 ordinary and 1 this entry. In how many ways you can arrange?
5 factorial.
5 factorial. That's all we have done, right?
Yes, sir.
Okay.
I
So it
got
will
it now.
be,
Yeah.
okay, it's clear. Should I consider another case? Let
No,
me take another case that will give you idea, right? Case 2 will be what? 4 special dishes, right?
And 3 normal dishes.
And 3
ordinary.
Yeah, ordinary or normal, whatever. Ordinary dishes, right? Now, 4 special means what? It can be, let's say, I'm just considering S1, S2, S3, S4, right?
Yes, sir.
And
So
3
5C4.
ordinary, O1, O2, O3. Now you will tell me what will the total number of ways. For this to select S4, how many ways we have?
5C4.
5C4. Now, just cover. Now, I can rearrange these things,
4
right?
dishes. Okay. So
In
4
how many ways?
factorial.
4 factorial. Now, how many ways you can choose?
3C5.
Sorry?
I mean 5C3.
5C3, yeah. Now, how many different items you have? 1, 2,
4.
3, 4. Now I can do again 4 factorial, right?
Okay. Yeah.
Same you have to do. Now tell me, it will be 5 special dishes
And 2 ordinary.
and 2 ordinary dishes, right?
Yeah.
Tell me one thing, 5 dishes means all are right.
Yes, sir. So we're gonna
And O1,
5C5.
O2. See, 5C5, that means 1. That's simple means,
Yeah.
right? So basically, we have selected, let's say 5C5. Now, in how many ways I can arrange within this?
5 factorial.
5 factorial. Now, in how many ways I can choose 2 ordinary?
5C2.
In how many? Now, what is the thing we have to consider? This is 1 entry,
3.
second entry,
3 factorial.
3 factorial, right? Just add this case because we can't consider the next case 6 special dishes because we have only 5 special dishes, right?
Yeah.
Got it? Yeah, yeah. Any other doubt?
Got it.
Anybody?
No, sir. Thank you.
Okay. Any other doubt? Anyone?
No, sir.
Sir, practice assignment.
Okay. Which question? Just tell me the. Okay, let me share my screen because question might be different.
Yeah,
Okay.
they are changing.
Yes, yes. They are. Once you do a refresh. Okay. Practice assignment. In which question you are doubt? One second. Is there is the question is there?
Yeah, third one.
Sweta wants to go Jammu to Bangalore by taking HARTS at Delhi and Nagpur during the journey. Okay, she has two options. Options of 2 flights and 3 trains from Jammu to Delhi. 2 trains and 3 buses from Delhi to Nagpur. 2 flights, 2 trains, and 4 buses from Nagpur to. In how many ways can she travel if she takes exactly 1 train during the whole journey? Right, that is the question we have. Okay, how did you approach? Any?
I didn't get it, sir. Like I just wrote the information and I didn't get it.
Okay. See, there are halt at Delhi and Nagpur, right?
Yes, sir.
So we can consider in sequence first of Jammu to Delhi.
Jammu to
And I
Delhi
do
and Delhi to Nagpur, Nagpur
Okay.
to Bangalore.
Okay, do let me know the numbers of flights and all, right?
Yeah. Okay.
So first. So if you see, so Jammu to Delhi, right?
Yeah, Jammu to Delhi, 2 flights and 3 trains.
Okay. So Jammu to Delhi, we have 3 trains.
2 flights.
Okay.
2 flights and 3 trains.
See, what is the question? She has to do. She has
She
to go
can
Jammu to
take,
Bangalore by taking horse at Delhi. Okay. So till Delhi, 2 flights and 3 trains are there, right? Nagpur. Okay. So since question, if you see, she takes exactly 1 train. If she is going
yes, sir.
to Delhi, so Jammu to Delhi, that means she has to take. See, for the train, how many options she has? 3, right?
Yes, sir.
Then 3 bus, correct?
Yeah.
And then total 6, right?
Yes, sir.
6
Sir,
means what?
you
Two
took like,
flight.
no,
Uh,
it's about trains, right? 3 trains, and then again 2 trains, then two
no,
trains. You took
no,
like
no, no, no.
buses.
If you see, she can travel if she takes exactly 1 train during the whole journey, right? So she can take the train from Delhi to Jammu only, or
Okay.
Delhi to 1 train from Delhi to
Nagpur.
Nagpur. We have to consider 1 train, right? So that means
Yes, sir.
she will be having 3 options for the train.
Yes, sir.
Are you getting my idea?
Yes, sir.
Then how many options? She can't use 2 train, right? Then she will be having 3 bus options for from Delhi to Nagpur,
Mm.
right?
And then two
Then
flights
six,
and
six,
four
six, six,
buses.
right? Are you getting? Basically, Delhi to Jammu. In case of Jammu to Bangalore, right? Basically, Jammu to case is she can use only 1 train, right?
Yes, sir.
So only 1 train. So if you see, we have to consider from Jammu to Delhi. I'm just writing in short, right? Jammu to Delhi, how many options she has? She can use the one case as a 3 train, right?
Yes, sir. Or two
Right?
flights.
Or plus, if
Two
you see,
flights.
rather than going like this, let's go like this. If you then Delhi to Nagpur, she can use any 3 bus, right?
Mm.
Any three
Yes.
bus, right?
Yes.
And then Nagpur to Bangalore, any of the 2 flights and 4 bus, right? Nagpur to Bangalore. So she will be having total 6 ways. That means 2 flight and 4 buses. Now, if you see to reach the Jammu to Bangalore, she is using only 1 train. She can use any of the train. Basically, there are 3 ways. Okay,
Yes,
three
sir.
buses, right? So now, what is the total number of ways? Like this, 3 into 6,
Yes,
right?
sir.
54 ways. If she
Okay.
is
Yes,
going
sir.
like this, right? Now, another case will be if she is using this train, this 2 train, I mean, in
Delhi
the
to Nagpur.
Delhi to Nagpur train, that means
Mm.
she will be how many ways? This is the case 1,
2 flights.
case 2.
So,
So, she can use 2 flight, right? Basically, she can use Jammu to Delhi, any of the 2 flight, right?
yes, sir.
Right? Let's write it like
It's
ways.
2
That
into
will
2
be,
into 6.
so ways, it will be flight, right? And then now C can you we can't consider this train, right? Now C can use
Mhm.
2 train, right?
Yes, sir.
So Delhi to Nagpur, any two,
Two
I will
trains.
be having 2 ways, which is
2 ways.
for trains.
Trains.
Now, then
Then
Nagpur to
6 ways.
Bangalore, we can't consider train, right? Again 6.
Yes, sir.
Are you getting?
2 into, yes, sir.
So Nagpur to Bangalore, it will be 6 ways. That means 2 flight plus 4 buses. Now,
Yes,
what
sir.
will be total
Which
number
is
of ways? It will be 2
24.
into 2 into 6, right?
6. Which is, yes, sir. 24.
24 ways.
Yeah.
Now, another case is there, right? What are
Last one.
this? 2 flight,
It's 3
three
buses
bus,
and 2 trains.
2 trains. That means 2 into 3 into 2, right?
So
So, which will be
12.
12 ways,
12.
right? So, we have to add this 12, then there's 24, then this 54. So, 54 plus 24 plus 12. So, it will be 90.
16. Oh, yeah.
Clear?
Yes, sir.
Yes, sir.
Any doubt?
No, sir.
Okay. Uh, Okay, then is there anything else or we can,
No,
right?
sir.
It's
Sir,
clear?
tutorial 4, sir.
It's clear.
Tutorial 4, what is that?
Sir, I also have one doubt
Hmm.
that one marriage problem they have shown, like 6 men and 4 women,
Mm-hmm.
3 couples are formed in a building.
Mm-hmm.
Can we do that using this for formula, like then drawing and taking the results?
Which formula are you talking about?
We can apply this NCR.
Yeah, you
thing.
can simply do. See, I think how many women you told me? 4.
4.
So to make a 3 couples, how many women you require? 3.
Yeah.
So you can choose simply 4C3.
Yeah.
So that formula I can apply, right?
Yeah.
Basically,
Okay.
both formula will be we have to apply, right? Like I mean that arrangement we have to think and then right? So it will be 4C3. Then think for first women, how many options we will be having, correct? How many options for the second women? How many
6
options for
men.
the
6
sixth,
men.
right? Then for the second women,
Okay.
5, right? For the third
Yeah.
women, 4. But if you
Oh,
see,
okay.
if you are going to select 4C3, that means you will get the 4 different combinations, right? So for those 4 different combinations, you are going to get 6 into 5 into 4. Then 6 into 5 into 4, 6 into 5 into 4, 6 into 5 into 4. Are you getting?
Oh, that's why into 4.
That's why into 4.
Okay.
Clear?
Yeah.
Okay. So, okay, what is this tutorial for? Let me see. 16 brown dogs running down, so that suddenly 2 of the brown dogs started following one black. So, okay. Had you gone through this video?
Yes, sir, but couldn't get the solution and don't know how to approach.
Okay. So 4 black dogs and 16 brown dogs are in running the ground, okay, such that no 3 are in a straight line. Suddenly 2 of the brown dogs think yes, right? Yes,
Yes,
you
sir.
are.
Yes, sir.
Yeah. What is your basically? Yes. Can you tell me your full name? It's like
What,
pronouncing
sir?
like yes. Can you tell me your name, please?
Aman, Aman.
Aman. So Aman, I will check this one, okay, and will let you know. Okay? I will check the things. What is the happening here? Okay.
Okay, sir.
Yeah. I will just remind me in the next session. Okay, I will check.
Okay, sir.
Because questions, I need to see this part. I will check it. Okay.
Okay, sir.
Yeah. Apart from anything else, this
No, sir.
no. Yeah, Aman. Now it's good to convert yes as Aman. Now it's okay. Then I think let's wind up. Aman, I will get back to you. Okay, I will check that one and okay.
Okay, sir.
Okay. Thanks, everyone. Bye. Bye. We'll meet in the next session.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank